Good day, everyone. Today, we will discuss Julius Plucker and his major contributions to mathematics. Before we start, let me read our learning objectives for this lesson. At the end of the discussion, you are expected to know the background and life of Julius Plucker, learn about his major contributions in mathematics, understand how his ideas influenced the growth of mathematics, and recognize the importance of his contributions in today's world. Who is Julius Plucker? Julius Plucker was born on June 16, 1801 and died on May 22, 1868. He was a German mathematician and physicist. Julius Plucker was born in a town called Elberfeld, which is now part of Wuppertal in Germany. He went to school in Dusseldorf and then studied at several universities including Bonn, Heidelberg, and Berlin. In 1823, he traveled to Paris, France. There, he was inspired by the famous French geometers who were experts in the study of shapes and spaces. After his time in Paris, Plucker returned in Bonn in 1825. By 1828, he became a professor of mathematics at the university there. Now, let's proceed to the major contributions of Julius Plucker in mathematics. First is the development of analytic geometry. He published his book about analytical geometric developments. In this book, he introduced a new method for solving geometry problems and he clearly explained an important idea called projective duality, which is about how points and lines can be swapped in geometry. Plucker wrote books that introduced a clearer and more efficient way to use algebra in solving geometric problems. Before Plucker, doing geometry with algebra was possible, but the notation was messy and hard to use. He basically cleaned up the system so that algebra and geometry could work together smoothly. This new notation made studying curves and shapes much easier. Second is the theory of algebraic curves, the classification, singularities, and cubics. In 1835, he published the system of analytic geometry. There he developed a detailed theory of plane curves of the third order, using both point and line coordinates. Think of curves like characters in a story. Plucker described how they look, how they behave at their problem spots, like sharp corners or crossing points, and how different curves are related. Before him, curves were studied one by one. Plucker treated them systematically, like organizing different types of plants in a scientific way. This is the beginning of the modern algebraic geometry. He published Theory of Algebraic Curves. In this work, he studied algebraic curves more generally, especially their behavior at infinity, their singular points, and asymptotic lines or conics. Most famously, he derived the so-called Plucker formulas, and algebraic relations that connect different invariants of a plane curve. For example, how the degree or order of the curve relates to its class, and how many singular points or inflection points it can have, and the like. These formulas allow mathematicians to deduce global properties of curves from algebraic data. Later in his life, after a period devoted to physics, Plucker returned to geometry in developed what is now called line geometry. His idea was to treat a line instead of a point as the basic element of space. Most of geometry starts with dots or points and builds shapes from them. But Plucker said, let's start with lines instead. This was unusual, but it helped mathematicians see space in a whole new way. His idea became the foundation of a new area of geometry. And the last one is the cathode ray experiment. The cathode ray experiment was a famous investigation done by Julius Plucker, later improved by Johann Hittorf, and eventually made famous by J. Thomson. This experiment helped scientists discover that atoms are made of smaller particles, specifically the electrons. To better understand this, let's watch this video.
The cathode rays experiment begins with a special glass tube containing very little air. Inside, two metal plates called electrodes are placed the anode and the cathode. The anode is connected to the positive side of a high-voltage battery, and the cathode to the negative side. Normally, electricity flows through a conductor, but here, metal electrodes carry the current through low-pressure gas. When the battery is switched on, an invisible ray shoots from the cathode toward the anode, traveling in a straight line. Scientists were puzzled. They knew something was coming from the cathode, but had no idea what it was. So they named this mysterious discovery cathode rays.
Importance of Julius Placker's ideas and contributions in mathematics and today's world. Julius Placker's ideas are important because they help change geometry into a clearer and more useful subject that we still rely on today. By improving analytic geometry and studying algebraic curves, we make it easier for mathematicians and scientists to describe shapes using equations, which is now used in engineering, physics, and computer graphics. His idea of treating lines as basic elements of space also became helpful in modern 3D modeling and camera tracking. Even his early work with cathode rays helped lead to the discovery of electrons, which is a foundation of all modern electronics. Placker's contributions may be old, but they continue to influence many tools and technologies we use today. And that's all for today. Thank you for watching.